Alright, sup nerds. In this question, they're asking us to find the smallest positive integer solution to the following system of convergence. So we're starting with 3 equations. So our first step is to choose one we're gonna set equal to one of the other equations. So first we need to solve for x. So I'm gonna pick the second equation. So I'm gonna rewrite this as x equals, and then you just take whatever is like this 5 mod 5, you can put the 5, let's just call it k is the variable, and then plus 4. So now I can set this x equal to either equation. I'm going to set it equal to the mod 19. So 5k plus 4 equals 9 mod 19. So now I'm going to solve for get k by itself. So I have 5k equals 5 and then mod 19. So then now I can do it the long way because I don't know how to do it in my head. So you take whatever this number is, the 19, and you want to find how many times 5 can go into it. So it's 3, so it's 15, and then remainder 4, and then you get 5 equals 4 times 1 plus 1. So when you reach this is 1, you know that's when you're going to stop. So now you go backwards, 1 equals, and then 5 minus 4. And then that's going to give you 5 minus, and then 19 minus 5 times 3. So then now you have negative 19 minus or plus 3 times 5. Or 4, not 3. 4 times 5. So then now we see that, okay, I care about this coefficient of 4 because we want whatever is going to make the 5k go away, and what we want to know what the inverse is. So the inverse of 5 is 4 in mod 19. So now we have k equals 4 times 5 is 20, so 20 mod 19. So if I rewrite this, 5k equals 5 and then mod 19, I'm just multiplying this whole thing by 4. So yeah. So now I know that this can be simplified further. I know that there's 119 that can go into 20, so I know this is equal to 1 mod 19. And I can rewrite this further as k equals 19. I'm going to just use the variable a plus 1. So now we have this equation, k equals 19a plus 1. And you're going to go back and you're going to substitute it in this equation, x equals 5k plus 4. So x equals 5k plus 4, which also equals 5 and then times 19a plus 1 and then plus 4. And that gives you 95a plus 5 plus 4. So that is x equals 95a plus 9. So now I have this equation, and this can also, if you want to rewrite it, you can say x equals 9 mod 95. So the reason why I do this is because I like to have, here I'll show you. So now we have left, so we used this equation and we used this equation. So all we have left now is this one. So x equals 2 mod, or is congruent to 2 mod 13. So I use a different color for this next step. I'll do it like right next to it. So x is congruent to, what do we say, 2 mod 13. So, and then I have x is congruent to 9 and then mod 95. I always like to have my bigger number for the mod. Like, I like to keep this in the mod form, whatever the bigger number is. So I'm going to convert this into like the variables. So I'm going to say x equals, and I'm just going to use b because I haven't used b yet, 13b plus 2. So now I can go ahead and write this. I can set these equal to each other. So you're going to get 13b plus 2 is equal to 9 mod 95. Oops. Okay. So if I simplify this further, I get 13b equal to, congruent, whatever, 7 mod 95. Now we do the annoying thing. 95 equals 13 times 7 plus 4. So then 13 equals 4 times 3 plus 1. I did this math ahead of time because I'm not going to sit here and do it on a calculator again. 1 equals 13 minus 4 times 3. And then that equals so then now we have to do it the let me fix this real quick. Like this. Alright. So 1 equals that, and then we also get that 13. Oh, I did not leave space for my. Let me move this down actually. Alright. Here we go. Give ourselves some space. Okay. So then 13, and then we need to substitute the 4, and this 4 is right here, so 13 minus, and then we get 95 minus 13 times 7, and then this whole thing times that 3 here, don't forget it, and then, so we're gonna have 22 13s minus 3 times 95. So, if we take a look and we see that, where is it? We want whatever's in front of the 13, so we're going to want this 22. So we get 13b is congruent to 7 mod 95. And we want this whole thing times 22. So we get b is congruent to 7, or not 7, well, 22 times 7, which is 154 mod 95. And this can be further simplified to say b is congruent to 59 mod 95. So now we can rewrite this as b is congruent to, let's just say 59t, or 95t plus 59. So now we have our b, and we go back and we plug this into this equation up here, this x equals 13b plus 2. So we're gonna get x is congruent to, I'll put a link in the description for the document to this if it's like hard to follow along, so you can just like have it open on the side. So 13, and then we substitute the b, so 95t plus 59, and then plus that 2. So this is going to give us, I don't know what this value is when you multiply these two, but we don't care because it's asking for the smallest number, or smallest integer that satisfies this x. So we know that we're going to set t equal to 0. So we don't even have to look at that. So all we need to know is this 13 times 59 and then plus the 2. So 13 times 59 plus 2 is, let me get rid of this. It's going to be 769. So I'm just going to leave this like this. And so yeah, so all we care about is the 769 because we're going to set the t equal to 0. If it's asking for the next positive integer, you're going to set t equal to 1, and then you're going to solve for x to get the next positive integer. So yeah, that's the answer to this question.